not one that I'm probably going to recommend that you guys do since it's a freshman course. Now we're introducing the idea of power, and it's using a capacitor. So it's kind of a bit more than what we need in this course, but for the sake of completion, I'll go ahead and walk through this lab. You'll actually find the capacitors in a box that looks like this. It's in actually the accessories kit, not the circuits kit. So that's where you'll find it. Just because it's a little bit more of a dangerous item, because it is storing power. It does note in the lab, do not use this with more than one battery. That's not what it's rated for, and so it's possible that it will pop. I don't think they're super dangerous. We're only dealing with 3 volts, but best to be safe with these or choose not to do this lab. First part, I'm not going to set up the circuit for the first part. It's just a simple battery, switch, and bulb, and they're measuring the voltage and the current with 1 battery and 2, and then calculating power from their measurements. So it's using the multimeter, getting the data, calculating power. They should see 2 batteries equals more power. I didn't want to set up that first circuit and then try to set this up afterwards and then accidentally have my capacitor the wrong way. For all the circuits so far and all the other labs, I haven't really cared about what direction the battery's been going. Do make sure that you note that the battery's going the right direction and that the terminals for the capacitor are in the right direction. These things are a one-way device, and so you don't want to mess them up by going the opposite way. It is kind of a cool concept for students who are maybe if you have an honors or advanced course, because capacitors are used all the time in circuits, computers, and all that sort of stuff. And so I'll show you guys in a second. If you watch the bulb, it won't get crazy bright, but turn it on. And you see, instead of it instantly getting, well, somewhat bright, it kind of slowly turned on. And now what happens when I take it off? See, it's still lit, and it starts to dim slowly over time. The battery is actually what I'm just connecting here. So the only thing powering the bulb at this point has been this capacitor. The capacitor gets charged by the battery once you've completed the circuit, and then after you've removed it, the capacitor is still able to discharge a current and a voltage for the light bulb. So that's why whenever you are like resetting a computer or device because it's having issues, you always turn it off, count to about 5 or 10, and turn it on. You want all those capacitors to discharge their current before you reset. So students will set this up. You can talk about the ideas there. There's questions. And then it moves from this to adding in more light bulbs and a slightly modified version of this, but still using the capacitor. And then the only other device they need is a timer, so you could use stopwatches or your phone, because power is, they're able to calculate, like, hey, how long is the bulb stay on? And what they should find is when you have 3 bulbs in a parallel circuit, capacitor gets drained quicker. So it's using up more power, because power is measured by how quickly something happens. And so then they're just kind of arguing from the evidence of that data that more power is being used quicker, and thus the capacitor gets drained quicker. So that's kind of the lab in a nutshell. It does collect some good data. It does introduce the idea of a capacitor. It may be over the head of most of our students. Well, the bell has ended this video, so I'll catch you guys in the next one.